So I could end up potentially with these two pieces of information now being pulled out of my database, passed through my embedding model kind of in a reverse fashion, going back to natural language, to text. And then that would be added to the user's prompt and then passed to the model.
Yeah. Okay, so this is interesting. So the vector database draws context out of what I have, puts it into my prompt before it gets passed to the large language model for the second run, basically, right? Because the first run is going to determine some keywords or whatever out of my natural language, right? Welcome to Embracing Digital Transformation, where we investigate effective change leveraging people, process, and technology. This is Darren Pulsford, Chief Solution Architect, author, and most importantly, your host. On today's episode, understanding generative AI RAG models with returning guest Eduardo Alvarez. Let's join this interview already in progress. This could be pretty incredible. I'm thinking just internally, like our sales organization, we're constantly hunting and pecking for PowerPoint presentations. Right? A customer says, "Oh, I have this problem." We go and spend hours looking for, hey, who's working on this and that? So this could help us quite a bit find information faster because it's a more natural language. I don't need a query language. I could just ask it, hey, I have a customer with this problem. What should I tell them?
Exactly. And that does bring us to, I think, a very important topic is that data environment before it goes into. So let's talk a little bit about the process of how you get that data into that database, yeah, right? So let's say, for example, that you have a knowledge base that's all in PDFs, right? You could scrape all the information off the PDFs. You could then, for example, filter out irrelevant information. Like let's say, for example, in your PDFs, you might have subtitles or captions or particular like trademark information or copyright information.
License on the end.
License stuff. Yeah. You just want to pull that out. You don't want any of that. You just want the meat of the knowledge. You take that out, right? And then what you do is you pass that through an embedding model. Okay. Well, after you've gotten all your documents, you're going to pass that through an embedding model. But before you do that, you're going to chunk your data up. That chunking size is basically a certain number, for example, of characters that are going to be in every string that is then passed through your embedding and then put in a vector database. So let's see if I have another pen here. Let's see. I'll search for one. Hopefully I do.
I have a pen, but I can't send it through the video. So.
Yeah, no, that one's not going to work. We're not there just yet, right?
No, we'll get there soon.
Yeah. So the idea is, for example, let's say you have, those set of documents, you process them to extract the important information. Then you're going to chunk them up into little bite-sized pieces that you're going to pass them with something called an embedding model. That embedding model is going to transform those chunks of data into a vector, okay? And then that vector is going to be placed inside of what's called a vector database. Per the name, it is a multi-dimensional database that stores vectors. If you remember your physics class in college or high school, a vector is just, a value with a particular direction, right? So in this case, for example, let's say that I have embedded information about Intel's, a question about how to implement Intel's extension for PyTorch to optimize a model and do auto-mix precision training in bFlow 16. So
that's pretty complex.
Very specific, yeah. Right? So I've extracted this information from the documentation on GitHub. And now this is what that vector looks like. Okay. And you can't see in 3D, but I can see in 3D because I'm in my space. But imagine this is pointing in a particular direction. That's a vector in the vector database. And now a user would come in and ask a question about how do I optimize my training using lower precision data types with PyTorch and Intel, right? So due to the keywords that are in there, due to how my embedding model and the quality of my embedding model, if it did this correctly, then when I pass the user's query through my embedding model and then I get another vector, that vector should be very close to that initial vector that has the stored chunk of information, right? Now, there might be more vectors in that same space that have similar information. So let's say that it's something like this. Well, what I'm going to end up doing is something similar to kind of like a nearest neighbor approach. And I'm going to say, okay, well, this one is the closest one, is the closest vector to my user's query vector. So I'm going to extract that information. But depending on how many relevant pieces of information I'd like to extract, which is usually defined by a parameter called K, I will get top K, number of retrievals from this database. So I can end up potentially with these two pieces of information now being pulled out of my database, passed through my embedding model, kind of in a reverse fashion, going back to natural language, to text, and then that would be added to the user's prompt and then passed to the model.
Okay, so this is interesting. So the vector database draws context out of what I have, puts it into my prompt before it gets passed to the large language model for the second run, basically, right? Because the first run is going to determine some keywords or whatever out of my natural language, right?
Right. So the vector database itself won't be responsible for doing that. It will be the whole retrieval mechanism. So you typically do something. Yeah. So you have to do the similarity search, then you'll do like an extraction phase where you'll pull out the nearest neighbors to your query vector. And then that will be translated back into natural language. And then there's something called re-ranking. If we have time, we can go into it. But essentially, it's a process of defining, which, out of those two vectors that I've extracted, which are the most important ones that will add the most value to the final results, or they're the most similar to the actual question. Yeah.
So this is actually pretty cool because I'm not retraining the model.
No.
I'm just giving the model more information based off of my context that I established with my RAG, right? With my vector database. So this is actually pretty cool because I could put anything in my RAG as long as I've created the vectors and then ask the same question of my LLM and get a different response back based off of the context that I established in my RAG.
Right. And that's a very important, again, we always I knew this was, when we started talking about, my background and the data and, understanding the data environment, that's where this becomes very important. I consulted with a company, before coming to Intel, about something, very similar. That's when RAG was very, very new. And they were basically trying to implement RAG. And they essentially had taken all of their data, knowledge in PDFs from the past 10 years of their products. 80% of those products didn't exist anymore, but they had just taken it.
They just grabbed everything
as it was, no pre-processing, dumped it in a database, and were expecting it to work. Not to mention, if you think about just almost 2 years ago, there wasn't nearly the amount of open source kind of LLM power that we have today. So they were working with something very simple back then, so I can't knock them too much. But at the end of the day, that data environment, the quality of the data, the freshness of the data are really what drives RAG. It's not at this point because we're taking the model for its language modeling capabilities. As long as you surpass a certain threshold of natural language modeling capability, you're going to be fine. And you really are just depending on how good is that how good is that database? How good of a job have you done with your embedding model? Have you selected the right embedding model? Have you selected the right chunk size? Is your data current and fresh? And that becomes the most important part. Yeah.
So I can't there's no super easy button on this. It's easier than training an LLM.
It's more predictable and more controllable because, for example, Darren, if I take information about old products and let's say I train 2024.Q1, version of my model. I fine tune that, right? With all of the information about my institution, and that's, that version of that model. How do I make that model forget this information about this quarter when it's no longer relevant in Q4?
Yeah.
You can't. Yeah. There are ways to perform something, perform model forgetting, but it's not a it's not a
It's not
deterministic
trivial.
process. It's not straightforward. Yeah, it's not trivial. So one of the great things about this is that as soon as the information is no longer relevant, you can just remove it from your database, and that's it, right? That's extremely powerful, right? Yeah.
So this is interesting because it's using some traditional data analytics techniques. Vector databases for search have been around for a long time.
Exactly. Yeah.
Right. So we're using some traditional data analytics in conjunction with LLM to create an easier way to interact with the traditional data analytics models.
Right. Right. And I think it's that familiarity that really attracts people to RAG. It's that control. Everybody wants control over their data. Everybody wants to feel that the exposure their data has to the outside world or even their internal organization is something that they that they have full jurisdiction over. Something that you can't really control potentially, again, when you try to explore some of the other non-deterministic methods to, again, perform fine-tuning. It's not one of I have said in the past that the ultimate superpower is taking a model, fine-tuning it on information that has a longer shelf life, that has a long shelf life. Things that are so critical to your operations that they will not change in any meaningful amount of time. In any short period of time. And then using that model to support your RAG. There you get ultimate alignment, right?
Gotcha. So a good case on that could be law. Yeah, there are established laws, right, that change never, right?
Yeah. Fine tune on the Constitution and and then perform RAG on the more thing. Yeah.
Yeah, I gotcha. All right. And that would prevent some of the crazy things that have been happening in law where people are asking ChatGPT and it's just creating case law out of thin air.
Right.
This would give it a little bit more validity. So RAG does a couple things, breaks down barriers to entry. Mm-hmm. I can do this in an afternoon or a couple days instead of months. Gives me higher reliability of the responses. Yes? No?
It's fair. No, that's fair. Absolutely fair. Yeah.
So more trusting. I can trust it a little bit more. And then also protects my data.
Absolutely. Yeah. That last one's a very important one, right? Because you might not want to ship your data externally to fine tune a model. You just don't let it leave your premise. You can keep it.
Especially top secret data. We deal with a lot of government, right? Oh, I can't have this data. Yeah, let's put all of our targeting algorithms up into the cloud and see what happens. That's not going to work, right?
Right.
Or what is it when we watch Mission Impossible? They're always watching out for the list, right? They're always trying to get the lists because it has everyone's right. I don't want that out in the open.
No, absolutely not. Data environments with LLMs are extremely sensitive, particularly when they have, personal identifiable information about users. One of the really interesting applications that I've seen that is very powerful from a data privacy perspective, but also just drives an incredible amount of just unique value creation from RAG specifically is for example, creating new generation recommendation systems from RAG where you can retrieve specific information about certain users, their search history on your website, their buying behavior on your website, and then use it to drive recommendations in the future. For example, you have all this knowledge about a user's history with your products, and you have that stored in a database. And when they go to ask a question, you can retrieve information about their previous products. Hey, remember you? Let's say an example. Let's say you and your wife share an Amazon account, right? And you're asking a question because you don't know what kind of filter to buy for your refrigerator. And then it's hey, remember you bought this refrigerator filter back then, and actually your wife just ordered one yesterday. Are you sure you still need to order it? Exactly. That kind of stuff is very
I don't
powerful.
even have to go and look for the model number for my refrigerator to go look up the right price. or the right
Okay.
product, because
Think about
it's
how
gonna know that information.
how you have like the marriage of your private user information plus the large database of institutional knowledge tied into RAG. So for example, you can retrieve vector. Let's say you have two different vector spaces or vector databases. One of them is about your private user information, and the other one is about all of the products on Amazon. Let's say, for example, right? Well, when you ask a question, first thing you're going to do is you're going to search this first vector database for information that's relevant to your user about related to the query that you just asked. You're also going to do the same thing and search it on the other side on the greater institutional database of all the products on Amazon. You can take context from both in order to enrich the response from the model. And I think when you start looking at those multi-database approaches and environments, it starts to get really exciting because you're because there's privacy here. This database doesn't touch that. Only person who has access to this is you as the user, right? So you can tie in all this richness of information, these different data environments, and have complete control over the access to each one on a kind of discrete basis. And that's super exciting, right?
So this shows me that I can have multi-RAG environments, right?
Absolutely. Yeah.
And multiple LLMs that have been fine-trained. In fact, there's rumors out there that ChatGPT-4 is actually several models, like 11 different models with
without a doubt. Yeah, most likely. Yeah.
Yeah, that's the rumors. So you see us moving in this direction where I don't have big, massive LLMs, that I have combinations of large or small language models, maybe even, or more context aware models that are augmented with multiple RAGs, and based off of questions, it will build results coming back through different chains of RAGs. Is that something you see happening?
Yeah, I think the complexity, and typically, this is called like LLM chains, as what a lot of people call them, is like using multiple models in conjunction with each other to support a pipeline of it that essentially is your user experience with your application. If you I have a company that I've worked with here at Intel. They're named Spiky AI, and they're part of our Liftoff program for startups. And I met them back in Boston at an AI summit. And when I sat down with them, when I sat down with them and talked through kind of similar conversation that we're having right now, it was really insightful for me because wow, I do this from a solution design perspective as Intel. But listening to companies that are implementing this, in the real world every single day, you see that it's not just talk. This is the right way to go about this. People are using fit for purpose large language models for different parts of their application. It's not a one model solves all potentially. And it's not really because it wouldn't make sense. Like if you just take a super large model and say, okay, this is the one I want to use, it could potentially solve all of your problems, maybe with some tweaks. You could just solve with that one super large model, but it doesn't optimize every step. You don't need that mega large model in certain places. You're going to have compute memory waste. So we always talk about heterogeneous computing, but then you have heterogeneous LLM distributed architecture.
Yeah, you have heterogeneous.
Well, right?
Yeah, this is very fascinating to me because it again decreases the barrier to entry. I don't need 1,000 machine, all running GPU hosted model. I don't need that. I can have a bunch of small LLMs around with RAGs and augmented and have context around them. So this brings up a whole new area of research and development that I think is going to be very fascinating. How do I manage the data going through these things, and the veracity of data going through them is going to be an interesting aspect as well.
Absolutely. If you read any of my recent kind of content that I've released over the past 6 to 7 months.
Well, you release it on Medium, right? That's your
on Medium. That's where I write. Yeah. So I like to talk about success with generative AI and AI in general, always from an operational perspective. I think about when technologies become very democratized, really it's the operational excellence that helps people succeed. If you think about an example I was using the example of Airbnb. Like when you have when Airbnb came into play, it came into being. Anybody could have their own hotel, right? So when you democratize the ability to host, to have your own mini hotel potentially, then it's really who can execute on their hotel the best. Because now everybody has access to the same tool. Everybody has the booking capabilities. Everybody has all this peripheral technology is taken care of. Now, what do I do to stand out with, in comparison to my competition? That breaks down to operational excellence. How do you manage that operation so that your margins are the best, so that, you have the right people cleaning your house? How much do they charge you? How often are they going? What are you including as part of your package in order to stand out compared to other people? Is that a competitive? How does that impact your bottom line, et cetera? So when I think about AI and AI in production, I talk about operational centric AI being a big focus this year, moving from other focus areas of AI, because now that we all have access to all these technologies, a lot of it's being done in abstraction. It really does feel like it's quote unquote easier than it's ever been. It's about how are good people going to execute. So that's where we start talking about optimizing the system as a whole. What LLMs make sense in these places? RAG.
When to use what?
When to use RAG, when not to use it, when to use a heterogeneous architecture, not only for your compute, but for your LLMs. There's a lot of really interesting opportunities and optimizations that you can do architecturally across your application now that a lot of this has been democratized, right? Now that it's
this feels a lot like the late 90s with SecDevOps. People don't think that DevSecOps happened back then, but it did. We were configuration management engineers or build meisters. That's what we were called back then. That's how I got my career started, was doing that. Because of the operational excellence, all the tools were out there. I understood how they all fit together.
Exactly.
And so you're saying the same thing. We're going to start seeing an emergence of real data ops and AI ops blending together to make this real, because you're creating pipelines and of data and interaction with different LLMs and RAG models. This is going to be exciting. This is exciting. No wonder your hand is stuck on the rocket. This is exciting times.
Fun stuff. Yeah, no, definitely. It's a good place to be. Yeah.
All right. So Eduardo, if people want to find out more and follow you, you're on Eduardo Alvarez on Medium. I've seen that out there. You post frequently. And good stuff, by the way. Very, very good stuff.
Thanks, Darren.
And if they want to find out more, where else can they look?
Yeah, well, I'm pretty active on LinkedIn. I'm pretty open to just having, conversations and chat. If you want to just, explore, just random topics about the technology in general, I'm happy to just chat.
Well, we're most definitely going to have you come back on the show, because you're able to bring these are really complex things. You've done a great job at bringing it up to a level where, a neophyte like myself, because I haven't been in the AI world for a long time. I abandoned it to go do other things, 30 years ago. So you bring it back to something that is usable. And I like how you said before, you're standing on the shoulders of giants that went before you, that worked on all these tough problems. Now you get to take advantage of the ease and create even more great technology around it. So
absolutely.
Great stuff, Eduardo. Thanks again for coming on the show.
No, it was lovely. Thank you, Darren. Thank you for having me. I'll see you next time.
Thank you for listening to Embracing Digital Transformation today. If you enjoyed our podcast, give it 5 stars on your favorite podcasting site or YouTube channel. You can find out more information about Embracing Digital Transformation at embracingdigital.org. Until next time, go out and embrace the digital revolution.